Swayam Prabha. Digital India. Educated India.
Okay, introduction. Why need IoT? Look at this. Why need data? We need data and informations to take the right decisions. If I have a data in my, look at you. If you have a data of all the informations of a different colleges and all, then you take the admission accordingly. So we need data and information to take the right decisions. Similarly, when there is so many electives in your institute, which one shall I take? Then your friend said, take this one. Then you ask him why. Then he gives you a lot of information about that subject and why it is good, why it is important. Then you take the decision. So for to get right decisions, we have to have a data and information. So who takes the decision in this world? All our information has to go to that, as I showed in my previous figure. All this information has to go to here in your cloud or your data centers. There your algorithms like ML, AI, and all kind of algorithms are running. So they will take the decisions to which one to select and which one not to select. So then the decision will come to you. So IoT devices or the network doesn't take decisions. These IoT devices sends the data and information through the network. Algorithms are here to take the decisions. Any kind of medical algorithms or all kind of things. So for that we need that. And IoT, so Internet of Things, a sensor device connected to the internet to collect data for which it is designed. So particularly for which it is designed, every sensor or IoT device, this is IoT device, we call it as a sensor or IoT device, which is designed for a particular function. I will give you a long list of functions. Look at this. Temperature measurement IoT is different from humidity measurement IoT. Heart electrical signals and sounds in front of our heartbeats, our signals and all has been coming to the brain signals, agriculture, robots, the robot has a lot of sensors, drones, cars. Your car has around will be hundreds of IoT devices, starting from your tire pressure to the engine heating to the air conditioning inside. There will be hundreds of close to it sensors or IoT devices, and all are connected by the networks inside the car and outside world. Buses, airplanes, smart home. In the home, when you before you reaching the home will come to know you are close by automatically. As you have studied many places, this kind of things. Your gas will be on, or your induction heater will be on. Your water will be hot. Your coffee will be ready. Like that, smart city with your cameras and your all your things being controlled by the smart city, traffic control, ambulance control, and all, etc., etc. All these different a long list, hundreds of lists of there where different IoT sensors have been put to get the data. So these data and information goes to your data center or the cloud. There those logical things are there, algorithms are there. They decide what to take action. For an example, in your home, if outside temperature goes up and you are sitting and you are feeling uncomfortable, the sensor inside the home will take the temperature to your controller, and air condition will take a decision. Let us decrease the temperature of this home. Let it make it cooler. So automatically, you don't have to do anything. You have to say, I feel comfortable in 23 degrees centigrade. That's all. And it will increase or decrease the compressors according to your requirements. Similarly, humidity, heart, and everything. So this information is very important. This information goes to the IoT devices. And IoT devices has three parts. One is the hardware, the small, tiny IoT device, hardware, electronics. On the top of that, a tiny operating system maybe there, which is very much customized or designed for that. And those are embedded softwares, and on the top of that, there will be small applications of for communications and connections of the information. So with respect to that, who brings the data from IoT devices? The data which is there collected by the IoT, the computer networks, like optical and wireless networks, brings the data to the data center, which I showed you. Who brings the data? So our role is who brings these data, these networks from your IoT devices to here. There are so many types of network: access network, core network, service networks. These networks carries it. But why it is so important? Why this 5G is so important? That question mark may come to your mind. That, hey, IoT I connected, simply data will go. What this 5G is doing, that part is very interesting. That means why I need 5G, for having IoT to be successful. If I want IoT to be successful, then I have to have a different network that is called 5G in the last mile. Why? Because if you look at heart signals, if somebody is normal, working fine, so normal signal will be going in every 30 seconds going when is a, but suddenly somebody fell down, a old elderly person fell down due to the heart problem or something. Similarly, same IoT devices become an emergency information within a millisecond, 2 milliseconds, 3 milliseconds, he will detect that he or she has fallen down and his heartbeat is not good, immediately inform. So look at same IoT devices become an emergency devices. Then the communication requirement becomes very fast. There should not be any failure in the communication, quick communication has to happen. So these kind of IoT devices have different requirements of performance. One is only temperature, maybe every 30 seconds, one temperature is going, and if the delay is by 1 second to reach the data center, no problem. But in case of heart, if in emergency, it has to reach the destination, 1 second means 1000 milliseconds in temperature case. But in heart, in 10 milliseconds, it should reach to the doctor. So look at the requirement from the network is different. One case 1000 millisecond, one case 10 millisecond. So looking at that, so wireless access network important has increased. That means that wireless network which is coming up to support IoT in present and future should have an installation fast. That means the IoT devices will be in millions and billions in number. It's not 1 and 2 in number. So that it has to be installed fast. I have to optical copper network takes long time to be installed. Supports mobility. If you're in wireless, you are using an IoT devices which supports mobility, like in ambulances or in your car, in all kind of IoT devices there, you are driving and it has to moving from one place to other. If I have a wire, there is a tail behind me, then I cannot move around. So mobility has to be supported. So wireless becomes more and more important. And less cost, wireless is less cost. And drawbacks, lots of research going on for high bandwidth. Wireless has one drawback is it's like optical network, it cannot give so much of bandwidth, like 10 gigabits, but still research is going on. From now it is going 100 megabits to the 1 gigabit is going on, but in a limited space. So still is lot of research going on how to increase the bandwidth. And reliability, because of the wireless, there is a possibility of signal loss, or that means the information loss. So reliability, high reliable communications are difficult. So now a lot of research is going on or the work is going on the reliability and bandwidth. These two are the lot of work is going on. But the advantages are so good, IoT likes it, because majority of the IoT devices needs connectivity. First, I need a connection with low bandwidth. Simply, if you look at all these applications, except the heart signals and all, couple of emergency, like temperature, humidity, agriculture, some car buses and all, smart home, smart city. Here, I want to send a small information, but delay is okay, no problem, delay is there and all. But some of these applications need very low delay, very high bandwidth. But majority needs, IoT devices needs low bandwidth and high delay, no problem. So these advantages are taking care of, those wireless networks are taking care of this kind of devices. Okay. So now, how many IoT devices will be connected to the network? This is a very interesting. One day I was taking class in somewhere in the IoT. One of my students told me, sir, how many IoT devices will be connected to this network? Then it was a very interesting question. I have been reading a lot of literature and all those papers and also all kind of books. But I found the people were talking about 4 or 5 years down the line, there will be 20 billion IoT devices, 50 billion IoT devices. But my student opened my eyes. He told me, sir, have you thought of like this? I was like, okay, can you please explain? Then he explained. I'll tell you how students also make us think. So he told me, sir, look at this. Total mobile is 4.5 billion in the world. In the world. Laptops, PCs connected to the network, say 1.5 billion. Tablets, 1 billion. So total 7 billion. This is equation number A. I just given a number A. So total 7 billion devices now connected to the internet. This is not IoT. These are all which human being is using. You and me are using. Now, due to smart cities, smart homes, smart cars, smart agriculture, smart health, etc., which I showed you a long list in the previous slide, there will be average 100 IoT devices. Let us assume. Assumption is 100 IoT devices per person. Why? Because the car has 20, 30 IoT devices. My office will have your office will have a smart 30, 40 devices of IoT, like temperature, fan, light, your chair, all kind of things will have IoTs, and your body will have all those people have a smartphones, your the smart watches that will have IoT on sensors on there. So if you look at, if an urban person uses 150 IoT and a rural person uses 50, so 150 plus 50 is 200, divided by 2 is equal to 100 IoT devices per person, which is a very conservative estimation of down the line 5 years, not now, down the line 5 years or 10 years. So if 100 IoT devices per person, then what is the population of the world? Population of the world is, assume the world population is 7 plus billion. It's not 7 billion, 7 plus billion. So 7 billion, so total IoT devices will be connected to the network will be 7 billion into 100 is equal to 700 billion. Please try to understand. We are now only 7 billion human being is using, and this is the 700 billion next 10 years maybe. So it is 100 times more within the next 10 years and connected to the network. Can you imagine? And that too, equation A, this is 7 billion, equation B shows 700 billion in next 10 years. So 1% means 7 billion versus 700 billion will be, so now look at this. So will be human and 1% will be human connected to the networks. Just see the ratio will change. Now in 4G, human beings are 99%, our machines are 1%. But when 5G will come and IoT device will come with those industrial revolution 4.0, the ratio will just reverse. 1% will be human beings, 7 billion connected to the internet, and 700 billion will be machines. So 99% machine connected to the networks. They will not talk to you. That machine will talk to machine. How? My machine temperature, the IoT devices in my room will study the temperature. He knows my comfort level. He will send it to the data center. Data center give a command, hey, compressor of air conditioner, please reduce the temperature in this room. Where human intervention is not there. And if you are driving a driverless car, you are not driving a driverless car, sorry for that. You are sitting behind a car, reading your files or the laptop, working for the office, and car is going driverless car. So somebody in Indian city, anybody come in front of the car any moment, and from any direction, top, bottom, right, left, God knows how the people drive in this Bangalore city. So can come. So within a 1 minute, within a few milliseconds, I have to press the brake. The car has to press the brake automatically. So the camera has to pick up, give a command. Somebody is in front of you and press the brake. That 5G network has to support that. Highly reliable, not a single information has to be dropped down, and it has to be connected. So look at those kind of problem which will come in case of this machine-to-machine communication, where human being will not have any interference or any decision making, no decision making, and this much of devices. This is an approximate number. I'm not saying that it will come tomorrow, 10 years down the line. And why this looks like everywhere, agriculture, everywhere it is moving. So now look at the network engineers or the scientists of the networking side, what a huge problem coming in front of us in the next 10 years. So we have to start working for that. And each application is also different. So this picture now, what you see, this 700 billion IoT devices will be here, user equipment here. And now without IoT, it is 7 billion now. 700 within the next 10 years, IoT will bring it. It may be in the robo, it may be in the drone, it may be industrial IoTs and industrial automations, all kind together. So now, with respect to this, let me go to the next slide. Let us assume 707 billion connected. 707, what I wrote, 700 is our IoT, and 7 billion is our own user equipments and devices. So 707, like Boeing, I wrote it down, 707 Boeing or 737 Boeing kind of thing, or 777 Boeing. So I wrote 707 billions connected to the networks. What will happen? Let us assume it is connected today. What will happen? Can you just see? You will really feel the pulse now. With 7 billion devices, mobile and laptops, so many call drops. When I come to office, I call my father every day, or my office works are there. I call my friends at least 2 to 3. Today I was calling to some of the deans of one of the islands. Twice it dropped down while coming. So many call drops in 7 billion connection to the same network. Okay, and quality of experience bad for the voice and videos. When you do a video call, when you are talking at home or outside, if you are not in on a cellular networks, you don't get that quality of experience what you want. And if you want to watch a cricket match, the bowler you can see, the ball you don't see. It goes so fast, 130 kilometers, 40 kilometers per hour. If you're watching on the internet, ball sometimes is not visible. So bad quality of experience. You are not happy. Today, I'm just saying, in 7 billion, and if you make it 707, can you imagine what will happen? When 100 times more devices connected to the networks, means 707 billions, what will happen to the quality of experience? Pretty bad. And moreover that, each IoT devices like emergencies, non-emergencies and all needs different quality of experience. Each IoT devices has a different requirement of QA. For an example, IoT of a driverless car may have a 1 milliseconds to response. 1 millisecond I have to respond. I told you, one child just come, driverless car is going in India, anything possible. A child may come running in front of the car. He was playing ball came onto the road. He's in front of you, in front of the car, and you don't know, you are reading on your laptop. Car has to brake. And to temperature transmission, 1000 milliseconds. So 1 millisecond to 1000 millisecond is 1000 times of quality of experience difference. And here you have to design a network, same infrastructure, no two infrastructure, same base station, same wireless medium, and same 5G network. One is catering, same infrastructure catering to 1 millisecond delay, same infrastructure catering to 1000 millisecond. How to do that? For an example, same road used for you to drive in a congestion, and same road, you want an ambulance to reach the destination within a 1000 less time in the same road, because you cannot lay down a road for every activity. For ambulance, one road; for your car, one road; for bus, one road. It is very costly affair. So same road, can I give an ambulance much faster movement? And when the ambulance is not there, how can I give other cars and a better quality of experience? But maybe delay may be high. There is no problem. So same infrastructure, like same road, two kind of demand. How to do that? It's not easy. So we need network to support above kind of differences. So what is the difference? This, you see quality of service from 1 millisecond to the 1000 millisecond in the wireless network, and also from 7 billion to 707 billion. For an example here, I have to support this kind of differences. How to do in same network infrastructure? Network infrastructure is same. This 5G network is same. One IoT device is telling me 1000 millisecond delay is okay for me. Another is telling 1 millisecond is okay for me. You please find out and design the network like that and support. Design means the protocols and the communications and network protocols and all. So support that. That is the challenge. You got it? So slowly, I am bringing you to a challenge that where and why we are going to face this. And these are the numbers, examples. So let me how to do it on a same network infrastructure. Is it possible? If not, where is the bottleneck? Okay. So these are the things. Now I will take you to the very fundamentals of the network, very basics, what you start in the BTech level and then MTech level, then we'll go to the PhD level. Slowly we'll move and you can able to understand every point of it. Let me go one by one. So what is the access networks? And standards take care of the access network. So standards, we don't talk in academia so much, but let me tell you, standard is extremely important for any product to be accepted. So what is a access network? I have shown you the picture of access network already. See, you have seen it. So this is the access, which is giving me access to the backbone, which you are not able to see. Backbone you don't do. So only you see these switches at home or Wi-Fi routers or 5G base stations or 4G base stations. What is access networks? Access network, the device or mobile laptop services, it's a get connected to a network is called access network, where you get first access to the network. I've already told you. Access networks are two types, wired and wireless access network. In case of wired, copper and fiber. But 50% of the world's access network is wireless, around 50, and it is increasing now. Why it is increasing? Because now wireless, if you read Wi-Fi or 5G, Their bandwidth availability is now much better, and reliability is also better due to the inventions in the technology of the wireless. But last 5-10 years back or 5 years back, people used to prefer more wired than the wireless, because copper and fiber, because in the access network, because the bandwidth was high and the reliability was high. But people are moving to wireless. So more, and now it is 50%, and within a 5-10 years, it may go to 60-70% of the whole devices on the wireless network. So IoT devices will also majorly will be on the wireless. And wireless access network popular are cellular network, this 4G, 5G, and Wi-Fi. These are the two most popular network in the world. If you look at till today, Wi-Fi access point is sold out, or I say Wi-Fi protocol sold out maximum in the world till today. And next comes the 4G, 5G. And 4G and 5G standards are done in 3GPP, third generation partnership project. Because if you are in the BTech or MTech going for a job, these companies, if you join any top MNCs or they mainly work on the standards and the standard kind of things, where this is called third generation partnership project. Okay, 3GPP, comes under the ITU. If you read any of these 4G, 5G's, 4G standard, 5G standards are coming up now, 4G standard all by the 3GPP. And Wi-Fi standard done by IEEE, Institute of Electrical Electronics Engineers. So now this is the thing. And we have contributed from IIT Bangalore, and there are 3-4 other institutes like IIT Madras, IIT Hyderabad, IIT Bombay, IIT Bangalore, around 10 years back, more than 10 years, 12 years back onwards, we have been continuously contributing to this standard body for the 4G and 4G advanced. Now we are moved to the 5G. And you'll be happy to know, very happy, this is a matter of pride for us, any Indians, that TSDSI, that is a standard body formed 5 years back, called Telecommunication Standard Development Society of India, that which recently, first time in the history of India, after 72 years, when we pushed first standard to the world, is called 5G standards for India, 5GI, which has crossed all the hurdles now in the standard body. Standard body, anything goes through is a huge time, energy, and effort. So it is in the last phase of the in 3GPP ITU, International Standard Body. If we will push through it, then India will have a huge contribution to the world in the 5G standard. Already 5G standards are coming up from the industry, only 5G standards. But India is pushing hard to push India-centric standards for 5G, which will be very much useful for the rural India and the urban India also. Because in rural India, our villages are there. There are 6 lakhs villages, because of, as Professor Minaki was talking about our contribution to the government for designing the whole country's network we designed in 2013, which is called State-Wide Area Network and National-Wide Area Network for the country, which is now rolling out. So we designed from collaboration with the Government of India, and IIT Bangalore was involved in that. So that networks, if you look at, there are 6 lakhs villages will get connected. And now those 6 lakhs villages, also, and that also now IIT Bombay also got involved, IIT Kanpur also got involved. Nowadays everybody in that 5G test bed got involved. So if you look at those villages, this 5GI will be very useful. So we should be feel happy. We are now evolving very fast in that direction. So now, as I said you, access network 5GI. Now let me go to the why 5G for IoT. Now I have given you an idea that IoT demands different services, different applications of our IoT demands different delays or different throughputs, from 1 millisecond to thousands of milliseconds. So same infrastructure of 5G, how I will give it? Is it possible? If it is not possible, where is the bottleneck? If that bottleneck we know, then comes the research or R&D, research and development. So now looking at that, what I explained to you a few slides back, that I need from 1 millisecond to 1000 millisecond of delay, then the need of flexible 5G architecture to accommodate diverse use case. That means same 5G infrastructure or architecture. Architecture means, let me explain what is the definition of architecture. Architecture means the topology of the network plus the protocols called as an architecture. Architecture is equal to topology. Topology means how I am connected, like star topology, ring topology, you might have studied in your bus topology in your undergraduate level. that is called topology, how you are physically connected, plus the protocols. What kind of protocol I use to for these communications is called architecture. So same 5G architecture has to be highly flexible to accommodate diverse use cases. Diverse means completely different 1 millisecond, so much diverse. Previously, what cellular network used to do? Only voice or SMS, or later on come videos. When I was student like you in I'm talking about mid of 90s. At that time, we used to discuss in our labs what will be video conferences on a mobile, how it will look. So now I'm talking about that 5G. What is architecture's definition? I said, are you able to hear the definition of the architecture? That topology plus protocol. Hello.
Yes, sir.
Then I'll start from. Thank you. So now that those kind of flexibility is needed. Then same network, same to achieve above networks is for to achieve this kind of flexibility. I am just telling you a term now, which I will explain you next slide. Very fundamentals of this. Very fundamental of this. The next slide called network slicing. Network slicing is a new concept coming in the 5G networks, which will play a crucial role to give you this flexibility, okay, to accommodate what? Diverse use cases. The diverse use cases means from 1 millisecond to thousands of milliseconds of data. So how to achieve that, I will explain you. Where is the first I have to go. So key 5G use cases and requirements. What are the 5G use cases and requirements? Look at this. Whole world's, all the application in the world, International Telecommunication ITU and 5G partnership project, they look at all the application of the world. They divided all the application in the world into 3 categories. As you know, I have already told you, more will be machines than the human being. Machines will be 99% of the traffic will come from the machine on the network. 1% will be human, just reversing. But human was 100% before, around 90s, late 90s, up to 2010. 2010 onwards, machines started get connected. Machine to machine communication I am talking, not human to machine or machine to human. When I'm completely machine, no human. So now it is slow, but very fastly moving towards machine to machine. So now ITU divided into 3 categories. One, enhanced mobile broadband, EMBB, which you are doing the mobile calls or you are doing these broadband video conferences and all comes under this enhanced mobile broadband. And it is enhanced. Why? Because quality of service has to improve. So mobile broadband in 4G is now given an enhanced word, EMBB. Please remember EMBB, okay? Enhanced mobile broadband. And another one is called massive machine-to-machine type communication, called MTC, massive machine type communication. When robo to server will give command to robo, go ahead, do this. So robo will be doing that. Or drone flying, it will giving command, drone to drone communication, giving command to each other, or same as massive IoT. So I told you the example of those your air condition going to and doing this. So you know human involvement or interference. So completely machine communication, 100%. Critical communication like ultra reliable, low latency, like driverless car example I gave. Completely car will be take the photograph, send it to the server. Take decision, shall I press brake or shall I press accelerator? Ultra reliable means not a single bit has to be missed, and very low latency. Latency means 1 millisecond, 2 millisecond, 5 millisecond. Those kind of applications come under this. So a lot of research and jobs are now URLLC, MMTC, and EMBP. So whole application broadly into these 3 categories broken down. And these 3 category has also subcategories under each one of them. So now I have to give a 5G network which will same infrastructure, but it will be giving catering to all these 3 bullets. Okay. So now let me go one by one. If I look at this example, just to help you, say URLLC. Where is the URLLC? Critical communication. You are ultra reliable, low latency. That means very critical. This yellow color. In yellow color, latency has to be minimum. So you see, latency is the more farthest away from the center. Mobility, if I am also if I am moving, and also it support mobility in case of like driverless cars. And also you see this yellow color is here, highly reliable, not a single information should be missed. Okay, and so these 3 combination means critical communication. Machine to machine communication in blue color. Look at connection density. There will be billions of devices will be connected. It has to be low power, because I told you 99% out of that 90% will be machine to machine communications for IoT devices. So power consumption has to be low. And these are traffic density, reliability can be low. So these are not so high reliable communication. Also, this machine to machine communications. And the mobile broadband, the green color. See, power, your mobile traffic density will be high, data rate will be high, because all of you are watching multimedia informations and all. Spectrum efficiency has to be high. So this is the green color one, which is it. So these three are the three different different demands from the same 5G networks. So how to design a 5G network? When a critical information comes, latency has to be lowest, reliability has to be highest. Same 5G network, when I'm using for a mobile phone, user data rate has to be high. He's watching a movie or cricket match, and delay has to be low or fine. But mobility, I'm moving in a train in a 400 kilometers per hour, but I am able to see the movie, downloading and watching. So they divided it. So IoT application, according to their requirement, belongs to the three categories. Okay, so now look, next I will be moving. Where is the bottleneck? I will go to our undergraduate level, then I will bring you to quickly to the very networking slicing level. Where is the bottleneck? Okay, so new use cases and why flexible architecture needed. Look at this. So use cases can range from means general broadband access with a global coverage, like your mobile call, or a specialized IoT like driverless car, or extreme mobility like a fast moving trains. You are moving and watching a movie in a train in your tablets. So use cases can range from these kind of three different categories. The utter difference between the use cases demand heterogeneous requirements from network. Everyone wants different requirements from the network. Cannot be satisfied by one size fit all architecture. Please be little attentive at here. I'm deep diving into the technology now slowly. So what it means that, so if I have a one architecture means, what is architecture? I explained you in the previous slide. Architecture means that topology part is common, I cannot change it, same topology, but plus protocol. The protocol, if is one same protocol, can I give 1 millisecond delay? Same protocol can be used for 1,000 millisecond delay? No, because each protocol designed for a particular efficiency or performance. So I cannot use the same protocol for such a range of different applications, from 1 millisecond of driverless car to another is temperature reading of IoT to sending somebody which is 1,000 milliseconds. So cannot be satisfied by one size fit all architecture. That means I have only one protocol. I am trying to solve all kind of applications. Why these applications has come now? Previously it was not there. You can ask this question. Yes, it was not there so much because of the IoT. We have put IoT devices in the air conditioner. Now IoT devices in the driverless car. I have put the IoT devices in your car for watching the engines and all. So now the different IoT devices come, so your applications have changed. If you look at the TV advertisement nowadays, they are telling air condition has intelligence to do this kind of thing. 10 years back, same air condition company didn't have that kind of advertisement. All our IoTs are there and intelligent decision making are there. So, but if you want to communicate those information for demanding 1 millisecond or 1,000 millisecond, this one size fit all architecture will not work. This question is, sir, I said you one protocol is one size fit, but what it is, explained in the next couple of slides. Please be little patient because this, and please attentive at here very much. I am going to next step of fundamentals, very fundamentals of the networking. Keeping above new requirements of the use cases in mind, alternative architectures are proposed in R&D to be done for the next. So alternative architecture means protocols, has been proposed. So one of the strong contending architecture is network slicing to solve this problem. If same infrastructure can give me 1 millisecond delay also, and can give me 1000 millisecond delay also. I don't have to change the physical infrastructure. So new concept they are introducing in a big way called network slicing. Please remember this word, which I'll be talking in the next slide. With the advent of new major chat technology like software-defined network function virtualization, operational management, orchestration, these are the new technologies which I'll explain you later. But first, I will explain you what is network slicing. So let me go to the network slicing, and these technologies are helping for the network slicing. Practically, what is one size fit all architecture? Practically, at present, no use case oriented architecture. Practically, if I look at your home, you are sitting at your home doing video conference, same Wi-Fi and same cellular 5G or 4G base station you are using for video conference, you are using for your voice call, you are using for the same protocol for your video games playing with your friends, and also sending email, browsing, everything. So practically, if you look at present, no use case for oriented architecture. Our architecture, the protocol doesn't change with respect to your requirements, use cases. That means when I send email, if it is 1000 millisecond delay is acceptable, my protocol doesn't change, remain the same. But when I'm doing a video conference, that where is the delay is only to 150 millisecond acceptable, that same protocol is used practically now. So any use case application services has to be same set of protocols like transport layer TCP, UDP, congestion control, routing. These are the protocols which is used are the same. Let me take you the figures. Limited inter-domain QoS mapping for end. So let me go why the present network cannot support 5G. Let me explain to you what I has written at here. Let me explain to you with figures, pictures. Then you will understand better. Why present network cannot support 5G? Can 5G be supported by this present network for different applications? Why not? Look at this. This figure is very familiar to you. The 7-layer architecture. Application layer, presentation layer, sessions layer, transport layer, network layer. This is all standard protocols done by a standard body called IETF, Internet Engineering Task Force, which is the largest body of the world who does the standard for this. All the protocols. And the bottom two layer, data link layer and physical layer, done by 3GPP. That 5G is here. If you are using cellular network, it is here. If you are using Wi-Fi, then IEEE, Institute of Electrical Electronics. Bottom two layer. But top layers doesn't belong to IEEE, it belongs to IETF. They do the all protocols. And if you you must have studied in your undergraduate or postgraduate level these courses. Am I right?
Yes.
Very good. Thank you. So now look at this. If I want to invoke any applications, now it will come from applications layer to the presentation, the session, the transport. In transport layer, if you look at either TCP or UDP, and TCP has the same congestion control protocol. If I have a 1 millisecond delay application, same TCP, same congestion control protocol. If I'm using a browsing which is 1000 millisecond is okay, I'm using same TCP, same congestion control. That means the TCP and congestion control protocol is not efficient enough to support my 1 millisecond kind of delay. They are efficient for 1000 millisecond delay. Okay, but TCP is so slow. If you have studied TCP and congestion control protocol, it is so slow, 1 millisecond, it will never give me. For an example, I'm saying only two protocols available, TCP or UDP. So one of them I can have to pick up. Similarly, if I come to network layer, is open shortest path protocol, OSPF, or if it is in the national backbone or international, it is border gateway protocol. Border gateway protocol is by default, and OSPF in a metropolitan area city. Inside the city, that's all open shortest path, or which one of them is given. And this is not efficient. BGP particularly not so efficient to give me 1 millisecond kind of delay or 2 millisecond kind of delay. So here is the huge bottleneck. I cannot use the same one fit for all kind of applications. So then look at this bottom two layers. Bottom two layers changing rapidly because a lot of physical layer research is happening, speed is increasing, data link layer happening, and these two layers has been optimized. But it is yet a lot of work is left. Bottom two layer, but moving very fast. So these top layers are damn slow, and it has not changed for last 40 years, 50 years, so much. Can you imagine when I was going, I have deployed in 2000, if I remember, OSPF for testing a backbone networks in a R&D, hardcore R&D, hands-on, after doing my research and all kind of work. And BGP, one of my friend was working on BGP. So look at this. So the thing is, what I want to say is that bottom is changing this protocol, and this protocol stack is in your laptop, in your mobile handsets, and your IoT devices will have these stacks. And here, this is not allowing me, this but TCP or UDP, OSP, top layers are not allowing. So I am not able to move fast. What to do? So same picture of this one I have drawn at here. Please be careful here. This is the very fundamental to understand where the next 10 years of research will move. And next 10 years of research, jobs, everything will move in that direction if I want to deploy 5G. So now look at the same picture of the previous slide, brought it here for your understanding. See, TCP or UDP, one of them you are allowed to pick up if your application is, whether it is a driverless car application, whether you are doing an email, whether you're doing browsing, one of you pick up. Same congestion control for both. And in the next OSPF or BGP, one of them you are allowed to pick up. And data link layer optimization, this is moving fast, good. But now look, if this is the situation, all of you will agree with me now, sir, the same TCP protocol, which is OSPF using for network layer, TCP in the transport layer with the same congestion control, may support 1000 milliseconds because designed for that. It may not support me 1 millisecond of delay. So now my TCP has to be invented for 1 millisecond. And it has to be optimized with the network layer routing, which is to be very fast to give me 1 millisecond. And data link layer physical access. So there has to be optimization from top application. The moment I invoke an application called 1 millisecond driverless car or robotic operations, which is 5 millisecond delay, then my TCP, my network routing, my data link layer physical layer has to be different from my simple email or browsing. Got my point? So now look what will happen. So upper layer not optimized with application. Upper layer means from network layer to application layer. It's not optimized yet. This is the bottleneck. This is the main problem. Okay, so if I am giving an example of Aadhaar, you know, everybody knows Aadhaar. Everybody has Aadhaar almost. So if I have a delay of 3 milliseconds in the network side, what is the 3 milliseconds? Say I am in the airport and I want to enter. No more. The government will say tomorrow you don't have to bring any identity. You have to go and look. If you are able to see me, say let us assume this is my device called Aadhaar device. I have to put my finger in the airport. Just put my finger, and it will carry my fingerprint and go to the data center in Delhi, somewhere in the Delhi outskirt of Delhi, and then it will go there. How many kilometers? 2000 kilometers from here to Delhi, from Bangalore to Delhi. And it will now in the data center search for 1.5 billion Aadhaar numbers are there, and search in the data center and come back to the airport and show on the screen. So you look at in India, people are very impatient. You know, if you are standing on a queue, behind person, hey, chalo, jaldi. So what will happen? So if you are in the airport, somebody is late to the airport and he wants to enter to the airport and catch the flight quickly, he will be pushing you, boss, quick. That means you will be given only 1 second to finish this job, your authentication to the CISF or in the railway station to your police. So authentication that you are the right person entering into the railway station, or you are the right person with the ticket entering into the airport. 1 second given to me, 1 second. Or maximum 2 seconds. So in 1 second, network part is there from here to go to the Delhi and coming back, network part, and there is a search in the data center, another part, and another is the display in the screen, your photograph, what is there in the Aadhaar and your names. So that will take some time. Electronics device takes some time to on. So 1 second means 1000 millisecond. 1000 millisecond divided by 3 parts: network, data center search, plus display on the screen. So you will get 330 milliseconds for the network. So now I have the same TCP routing, everything I use, then I will not go and come back in 330 milliseconds from Delhi. Millisecond I'm talking. So I have to invent a new applications layer protocol. I gave the name called application 1 layer protocol, TCP1, UDP1, routing protocol 1, and MAC1, PHY1. it will be 5.1 means this device will be 5.1 going on the 5G with the Mach 1, and the backbone also has to also for faster routing protocol. This will be OSPF1 or BGP1 and TCP1 or UDP1 application. So these all set of protocols has to be optimized top to bottom. Give me 330 milliseconds. One set. Another set of protocol, and same 5G base station, same routers, same because infrastructure is same. I cannot have a different infrastructure because it is very costly and space. So next is another application came in called driverless car. 1 millisecond, same infrastructure is demanding. Then I have to invent another set of protocol, application 2, TCP2, routing 2, MAC 2, 5, which will support me to optimize and give me 1 millisecond. Another came video games. You and your brothers, sisters, friends playing 50 millisecond is my demand. So I have to have another set. So for different applications, I have a different sets of protocols, and it is optimized from so top to bottom to give me this much of delay. So look at this, same base stations routers or same routers on the backbone, same these devices has to give me 3 different according to my need. So this one is a please listen to me carefully. This is a one slice of protocols optimized to give me Aadhaar kind of application. These driverless cars is another set of protocol called another slice of protocol inside the same device. Give me 1 millisecond. Another for my video games, this is another setup. So this is called slicing. This is called slicing. Fundamentally, this is the slicing in the same device. Maybe my mobile handsets, maybe IoT devices, maybe the base station of the 5G, maybe the routers. So invention has to happen and optimize from top to bottom to reach to that delay. Got my point? So this is called network slice. Previously, on the left side of the figure, you see I have the one OSPF, a routing protocol, same TCP, and I am asking him the same TCP, same routing, same application protocol to cater to all kind of applications, which is not possible because my delays are different. Okay, so to this is the research problem. I made it very simple for our understanding. This is a very critical research. Every layer we have to deep dive, understand, and optimize from top to bottom. Optimization. Now only optimization is happening between data link layer, physical layer, because physical channel condition and all they are optimizing, or some research problems are there between transport layer and physical layer, from top to bottom, physical transport, fourth layer to here. But top to bottom, very complex. It will happen one day. I am sure you people will do. I might have been retired at that time. I don't know, but it is a pretty good problems which will happen, and industry is moving towards that. All research will move towards that direction. These are the visions to what. So again, I am saying when I was student, I do a lot of single row wise research happened. Every layer wise. Physical layer people completely used to do physical layer. MAC layer people used to do only MAC. Routing layer people used to do routing. But now if I go to any PhD student last 10 years, they are doing MAC and physical layer optimization. So slowly, last 10 years is going on. Slowly it will go to up to applications layer. And optimization has to happen because people are demanding like that. So this is called slicing. Okay, network slicing. Each protocol will be optimized from bottom. Any questions you have? Let me go a little bit deeper. So now, what about the intermediate nodes between the source and final destination? All the intermediate nodes like routers, switches, this is the source. It is all the 5 layers are in the source, or 7 layers in the source. Why I shown 5 layers? IETF standard layered the network into 5 layers, IETF standards. But in OSI standard, which you study in your books, they say 7 layers. Top 3 layers, they merged it to applications layer. So it became a 5 layers in case of IETF standards. And intermediate nodes like routers, switches doesn't have the top 2 layers, application layer transport. They will have only bottom 3 layers. If you remember, routers, switches have only bottom 3 layers. So all, if you come to know something going for Aadhaar, so routing protocol 1, MAC 1, 5, 1 of the routers, intermediate nodes will be get activated for Aadhaar kind of session. For driverless cars, this protocol 2 routing, MAC 2, 5 2, physical layer modulation techniques will be get activated and help you to do the communication. So intermediate nodes also will come to know what kind of application is coming, and they will get tuned to that set of applications will get activated for your session. If you are doing a voice call, one set, same mobile I am using for a video games, different set. And intermediate routers will be informed according to my session number. My session number will move from me to my destination. So accordingly, these slices will get activated to give you the end-to-end performances. So look at this, same thing which I explained to you, I'm pictorially showing. This is me, say this host H1 and host H2 is you. Okay. So if I want to go from my host to you, I am crossing my city backbone, this one, this red color. Then I am crossing the national backbones. Then I am crossing to reach you. Okay. So now this is called intra-autonomous system. This red one, the green one is inter-autonomous. Autonomous system means different companies route networks are different autonomous systems. Say I have taken service from Airtel and national backbone is from Jio and you are in a BSNL. So it crosses through different network. Each network is called one autonomous systems. So now delay calculation. So if you look at delay calculation, so in each hop, there will be queuing delay, processing delay, transmission delay, propagation delay. So if you look at each one, first is queuing delay. Packet comes, stands in the queue. When you become the number one in the queue, front of the queue, we can processing delay means routing algorithm starts or other kind of MAC algorithm starts. Then after that, decision made to transmit which direction. Then transmission happens. Then the propagation. Then you reach the next hop. Again, next hop will have a queuing delay, processing delay. Every hop you have these 4 elements there. Hence, each layer protocols to be optimized from application to physical layer with respect to requirements of an application. So please try to understand delay word which I used 1 millisecond or 1000 millisecond. But if you deep dive into the delay, each hop like base station, your laptop will have these four elements. Everywhere these 4 elements. These are very fundamental. And all these add to your delay. And when you reach the destination, a target given to you 330 milliseconds, you have to see that my queuing, processing, transmission, propagation, everything has to finish within 330 milliseconds between the hops. And look at this. The most difficult part is queuing one, which is very difficult to predict. Propagation delay part is constant, transmission delay is constant, and processing delay almost constant. So these 3 are constant. But queuing, you don't know how many people are standing in front of you because it is a bursting network, internet. If you have stayed in a hostel, if you will see that sometimes your hostel network is very good fast, sometimes very slow. Why? One of your friend happily watching movie, downloading movie and watching. So he blocked your network slow down like that. So EV in Bangalore and server in California, only propagation delay is a 5 microsecond for 1 kilometer. From here to California, San Francisco, 14,000 kilometers, so 70 milliseconds. Only propagation in the fiber. I am not talking about queuing delay in each router. Every 100 kilometers, there is a router or something like that, and transmission delays. So in one direction, 70 milliseconds in one direction. EV in Bangalore, Aadhaar server in Delhi, only propagation delay is 5 microsecond per second into 1 kilometer, so 2010 milliseconds. Only propagation one way. So this is only propagation part. Transmission delay, presentation delay, queuing, all you have to add up and you have to design for optimizations. Okay. So now I will be those calculation I told Aadhaar, it is being written down at here, how it has been broken down. This 1000 millisecond to 330 millisecond, which I have explained to you in the airport. Similarly, the driverless car and the 1 millisecond remote surgery, robotic surgery. It is becoming very hot topic in medical science. If your brothers, sisters are studying in your or uncles are there, ask them. Robotic surgery is a very important now, and it is a hot topic now in the whole medical world. A lot of surgeries are possible, and so but delays is expected, and no loss. Not a single bit is allowed to loss because you are doing operation. If you are nerves are there, fine nerves are there, arteries are there. If you're not able to see properly, sitting at in India and doing operation in Russia, and you are not able to see, then it will be a problem. So hence, service-centric architecture is coming. I need this service and application, and my application layer, transport layer, network layer, data link layer, file layer will be defined and optimized. And multiple TCP UDP routing. So I explained you top to bottom has to be optimized, and it has to be implemented to give you a network slicing kind of things. Okay, so now before I move how 5G is going to do that network slicing, anybody has any question, you can ask me now. Also, you can ask me later. I am giving you 10 seconds to ask questions, and I will go, because this is a very fundamental thing to understand what is network slicing, because we will be working in this area within a few these areas, very short. And you have studied this left side you have studied, okay, but right side is the future.
You could unmute and ask. Yeah, please go ahead.
So you said that this network slicing needs switching between different set of protocols according to the application we need. So possible to design a device, such a complex device, which will switch between certain set of protocols according to our service we needed. So
Yes.
it's so complex, right?
It's very complex, very complex. But look at this. Look at your own mobile phone, own laptop. It was so simple 10 years back. You know, my mobile phone didn't have a camera. My mobile phone didn't have anything except a voice call and SMS. Now look at your mobile, because if a human being requirement is utmost important. If requirements comes from the human being or ecosystem, anything, not only human being, ecosystem, that I need this from a technology, whole world, the scientists and engineers will try to solve it. So I know it is complex, and you also know it is very complex. That's so nice of you to have said that. But people will find out a solution. And let me tell you, another beauty of the engineers is that you will make it so simple, this complex system, that the user, common man, you see, like you engineers are only on this earth is 0.001% of the world. 0.001%. Rest 99.999 is users. Mobile phone, everybody uses, starting from a farmer to a president of India to president of US. Have they invented mobile phone? Any of this protocol? No. President of United States also, not India also, right? But they are users. They look at the mobile phone, looking at the symbols, they just touch. They have been that much. Wonders happen. Whole business is running by touching the phone. They are not none of them is inventors, except 0.001. So these are the two things. First, understand the complexity of the problem. Engineers are, and they solve it. Then they make it so simple for the common man use it. So please don't worry. Get rid, think how to solve these problems, how to make it simple, and you use it. And machine type communications will be so intelligent. Human being may not have to touch anymore, only speak. You see, nowadays mobile has come. If I say connect Divya Darshini, my phone will connect to you. I don't have to touch also. But it's so simple. Think about an elderly person who has a Parkinson disease. He's not able to touch the screen, but he wants to talk to his daughter or son, to whom he or she loves so much. But previously it was not possible. Now, see, keep the phone on the chair or table, says connect my daughter, period. So look at how simplified, and do you know how complex it is behind the scene? It's very complex, I agree with you. But these applications, the logic, the software and the hardware, and you people's invention, the algorithms will solve these problems, very complex problems. It is, I agree with you. But it will be solved.
Sure, sir. Sir, I have another question.
Go ahead.
While switching into 4G to 5G, you said that we have three networks, that's access network, core network, and the service network. Whether we have to modify the entire three set of networks, or else we have to employ smart antennas and these and all in the access network itself.
Very good question. Very nice. You see, let me go step by step. When you bought your laptop, okay, you are going to use it for how many years? 4 years or 3 years? but in between there will be different Linux operating system will come in. Version say 10, then the 12, then the 14 and 15. But do you throw away a laptop? No, only software part get changed. Similarly, hardware part will remain same. When your same router, same processor, semiconductor, I will download the 5G software, the stacks, the software, these stacks I'll be downloading there. And in the antennas, if it is changed, only the antenna part will change. But if the antenna will be designed to tune to another frequency, that will be done by the hardware connected to the antenna. No need to change the antenna also. So the hardware and softwares, hardware changes will be minimum to minimum in future. Softwares will change. And same infrastructure, today 4G, tomorrow it will be 5G, next day 6G. So there will be hardware buying cost will come down. Only you have to buy the software stacks to change. That is the idea now. Okay, that is the idea now. But then it will be a very costly affair if I throw away the hardware. That is point number one. Point number two is very important to understand that medium never changes. Same optical fiber wireless medium. See, this is the wireless medium. You can see I'm making my hand like this. I'm touching the wireless. In this wireless medium, there are hundreds of radio signals are there. TV signals are there coming from Tata Skies to all skies to here. And your Wi-Fi signal is there in my room, and my all 3G, 2G, 4G, 5G, all are here in this room. So if I'm making my hand, I'm touching all radio signals. I'm not able to see that. So this medium of wireless will not change, but the radiation from the antennas will be moving through this wireless medium. And your devices will catch that. And your optical fiber medium and the backbone also will never change. But the routers connected to two optical fiber and the protocol stack in that will change. Okay.
Oh, okay, sir. Thank you, sir.
Good questions. I appreciate that.
Yeah,
Let me go to the
Professor
next.
Das, there is one last question from Mahima in the chat
I'm
box.
sorry,
She's
I'm not able
asking-
to see.
Yeah, no problem.
Thank you,
We'll read it
Professor.
out.
Thank you, Professor.
She's asking, how can we utilize cross-layer communication for network slicing?
Cross-layer communication, I think he's asking two questions. One, optimize means like data link layer, physical layer. Let me give you answer to your question, Mahima. Please listen. This physical layer is connected to your antenna. Antenna is connected to your wireless medium. Wireless medium changes continuously. Okay, why? Because you are close to a good wireless condition. Suddenly heavy rain started, wireless medium also changes. So immediately the control signal connected between you and the base station will inform your UE that signal strength is going down because of the medium condition is changing. Then the phi, look at my mouse, this phi will inform the MAC, you change your scheduling algorithm. Don't send me packets so fast because medium is bad. I'm pushing the packets, but it is not reaching to the base station. But they have a constant exchange of control signaling about the medium. So what happened, the moment he informs this MAC, they optimize the speed from MAC to phi and phi to MAC. Got my point? So this is called optimization between these two layers. And can it be done across the layers? Can the router has to be informed the MAC, you slow down, then transport layer has to be said slow down or go fast. Maybe both are possible, slow down or fast. So that will be that is called optimization. What is the optimum speed I should carry to reach to this, get this much? So direction for 5G to support IoT. Which direction this 5G is moving? So as I told you, to support IoT. So architecture is equal to topology plus protocol. The protocol means communication rules. What protocol? If you have studied applications layer protocol for browsing, HTTP protocol, hypertext transmission protocol. So HTTP or TCP, transmission control protocol, or UDP, all those things are called protocols, communication rules. So in what direction the 5G is moving to support those networks licenses. So now look at it. Worldwide, various standard bodies working on 5G, as I told you. However, industry and academia agreeing to following complementary views, which is driving the present research in academia and industry on 5G. One is called evolutionary view. One is called service-oriented. Evolutionary view is generally very hard. They are telling throw away everything. All routers switches have 4G and before 3G and all, throw it to the Bay of Bengal or Arabian Sea invent from the scratch. But it is a costly affair. Already the service provider has spent, you can't imagine, in India itself, each one of them for 4G has spent close to 30,000 crores to 40,000 crores to upgrade from 3G to 4G, their base stations. So if you'll ask them, throw again buy a 50,000 crores of devices, they will be in a red, they'll be in the huge loss. So they want a evolution, when they should go in a step-by-step, service-oriented views kind of, they are talking about. So evolutionary view is a natural transition from 4G to advanced 4.5G and focusing on significantly improving the efficient mode. So traffic size is increasing from 1,000 times from now. Traffic is increasing because everybody is watching nowadays movies, video conferencing and all. No more voice calls or SMS. And 100 times or 1,000 times devices are coming in, from 7 billion to 700 billion. 100 times new devices like IoTs and all. Throughput is going up by 100 times. Delays reduced. It has not multiplication, it has to be divided here. And spectrum efficiency 2G to 4G increased by 30 times. Same spectrum, same frequency, I am able to transmit 30 times more bits from 2G 1992 to 2000. Within 18 years, the research has gone up by 30 times. 5G will be much more efficiency in the spectrums. So this is called your evolutionary process. Service-oriented view is that is envisioned to cater a wide range of services from traditional human-centric to machine-to-machine communication, which I said you, human means voice and human videos, to machine-to-machine communication like driverless car, robotic operation and all. It requires same physical infrastructure of the network to take different forms depending on the service requirement, naturally to the notion of network of slicing, which I explained to you. This we are talking about that service means application. If my application demands 1 millisecond, how my network will give 1 millisecond delay? If the same infrastructure, same physical infrastructure demands 330 milliseconds for Aadhaar, how can I give it? If I want a video game, so that is the naturally heading for a network slicing. So network slicing is a service-oriented view required for a radical rethinking of existing mobile and backbone networks architecture with more flexible and programmable network systems. So more flexible and programmable. Why programmable? I said more software. If I change the software, everything changes like that. So, and it will be very high-speed software. It will be embedded kind of software. It is not slow softwares like we write Java and all. These are high-speed machines. The above possible by leveraging new technologies like software-defined network, SDN, and network function virtualization, management and all. I will give you an example very shortly. What is SDN and all in my next slides. So it will help you to understand what is going to be your next networks and how it will work. So before going to that, my explaining you this one, this is very, 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 and now if you go to any companies, MNCs and all, they are mainly working on software-defined network function virtualization, management of the networks and operation. So of the 4G onwards, 5G networks, or even though if you go to any, not 5G, 4G also, the routers, switches like Juniper, Cisco's and all, they are also working on this because these are the futuristic to support those service-oriented kind of things. User is God. User means common man is God. We are also user. Please try to understand. One side we are engineers, we are also user. We demand from the network different things, and network has to give that. So before I come that, so these kind of things, same physical infrastructure, giving slices of the network for different applications looks like this. Look at this use case of the network. Same, if you look at this picture, same network infrastructure. You see 1, 2, 3, 4, 5. These routers are there under a base station. You see, same. They're connected with the fiber in the same manner. Okay, same infrastructure, same physical infrastructure, routers, switches, base. These are maybe the base stations. Okay, correct. You look at this. According to my requirement, if I'm a smartphone, I am doing a video conference. These are my phones. And that means radio access technology 1 and radio access technology 2. Radio access technology may be 5G and radio access technology 2 means 4G. They're connected to the same infrastructure. I am demanding different video conferencing I'm doing or voice call I'm doing. This slice will give me that much of delay and throughput for my demand from this mobile. But same infrastructure you used here for giving me automotive devices like driverless car. Delays become from 150 millisecond of video conference to 1 millisecond or 2 millisecond at here, automotive driverless car. Same infrastructure. And here my driverless car is going and human being is walking. If he comes in front of the car, he has to brake. How to give a quick decision and communications. And same infrastructure, you see, this is another slice of protocols. This is another slice of protocols. This is another IoT devices. And other slices you can see, but over the same infrastructure. So it looks like this, as if there are different slices over the network to cater to your requirement, human requirement. Human being as a common user will not differentiate between this. So quickly, I will make you understand at here how it will be. Look at this. This is our classical telecom network. It is you, landline, or your 2G phone, and your parents are sitting at here. The moment you dial at here, then look, this line, this side is transport layer. This is actually in telecom language. Transport is nothing but data. Data goes. Voice is a data. Video is a data. Or SMS is a data. So that is called as a transport information or data information. And above the dotted line is control layer. It controls the info. The moment you dial, you are not talking at that time. It goes to the control layer, signal point. Okay. And it finds out what is the destination. So when you dial anything, you find on your mobile or on your landline, beep, beep, beep sounds. Then ringtone happens. That beep, beep, beep sound is the time duration when which is finding out where is the destination. The moment he finds out the destination, then the ringtone happens. At that time, voice has not gone. The ringtone means in the destination it is ringing if it is not busy. Okay, that destination. So if that person picks up, says hello, then this voice goes to the destination. Then you comes down to the transport voice. So signaling part is over. So there are two things. One is called signaling. One is called voice data. So now this concept of the telecom is now transferred to now because everything is now over the internet. So this is our SDN, software defined network architecture. This is my data part. This part carries my data, my voice, videos, video games, all kind of things, driverless cars, whatever it is. And this is my control, SDN controller. This is the control. Before I explain to you, let me give you an example first. You see, you are in the college. Your college is just get whole days classes are over. You want to go to home. You went out and you look at your watch and you have to catch a bus. So you saw now 5:29 p.m. 5:30 p.m. bus will come. 1 minute is there to reach the bus stop. So what you will do, if you calculated in your brain, hey, if I walk down 30 seconds or 45 seconds, I'll reach the bus stop, I will catch the bus. So then you start walking. Who calculated in your brain calculated 60 seconds is there. Then brain calculated 45 seconds, you will reach walking. Then the brain gave you a command to your legs. Leg doesn't calculate. Leg doesn't have neurons to calculate anything except the communication part of the part. So then your brain gave the, okay, you walk on this speed, 5 kilometers per hour speed to your muscles of the leg, then you walk around, say, talk to your friends and walking, reach the bus station and catch the bus. But you looked at your watch, now it is 5:29, 40 seconds, means after 20 seconds, bus will come and go. What will do? Same brain will tell your legs run, same legs. Yesterday you walked, today you are running. Same legs, same muscles got a command from the brain, run. See, that is called controller. Brain is your controller. So this is the controller. It will give the command to these muscles here, muscle powers of the routers and switches of muscle power. Hey, this packet is high priority. Don't make it delay. Forward it first. So if it is a driverless car packet, move fast. give him more bandwidth, give him more computation facilities, forward it put him in a special queue, forward it like ambulance. So this is the called slicing. And these muscle powers changes according to your requirement, according to brain signal. So this is called network function virtualization. Same machine virtually allocating sometimes less CPUs, less buffer or less bandwidth, and according to your demand, giving you more CPU, more buffer, more bandwidth to move fast. So this is the interesting things. So this is your brain of, like I explained, and this is the must. So like this slicing of this will be there. Same infrastructure, but as I explained to you, it will be working on different slices. And due to this brain. Okay, I have only 2 minutes left, 3 minutes left. So I will stop within a 30 seconds to, if you have any further questions. So you must have understood this. So as my mom was asked, so this you can see, this is you, your friend, he's here, you want to play video games. So control signal will first go, this controller will say, connect these switches with this much of CPUs, this much of bandwidth, this much of this, and this gives you that, and you. So this is where your session will go in future. So this is another one of the SDN architecture, because this is the wireless part. Somebody was interlayer of how to work. Interlayer doesn't mean only the layer vertically, but also wireless layers are different from the optical. SDN control in the optical, SDN control in the wireless. How to map my requirement efficiently, so then you will have a end-to-end. So this is one of the work went from our lab in IEEE journals, TNSM, in 2017, long back, because research happens always 5 years ahead of time. So I will stop at here, and because network function virtualization, I have already explained to you how it works. So I'll go back to my previous picture, this one. So this is my future along with 5G slicing, network slicing, how it works. If you have any question, please ask me.
Yeah, like before, you could unmute and ask, or type in the chat box and we can read it out.
Oh, chat box is there, no? Okay.
Sir, good afternoon, ma'am. Am I audible?
Yes,
Very
yes.
feebly.
Okay. Am I audible now? Is it better?
Yes.
Yeah.
Yeah. Okay. Good afternoon, sir. Thanks for the detailed understanding on how 5G and IoT are going to work together. I just have a question that what is your take on security and privacy issues that would come up when we adopt 5G for IoT?
Yeah, very good question. I really appreciate. Security and privacy are two different things in many respects. Also, both are interdependent on each other. Okay, so security, that is already taken care of. A lot of good works in security is happening. It is a green subject, evergreen subject. Always there will be a lot of challenges in the security. A lot of research is happening to solve those things. And 5G security taken care of. A lot of work has gone in. Privacy means that I want some of the information to be disclosed to some parties. Sometimes I don't want to disclose. So that comes under the privacy part. So that also, that to give privacy, technology has to be invented. Technology, without technology, I cannot give privacy. So privacies, there are already privacy protocols are there. You might have seen in your mobile phone that if you want to share these things, you click this button. If you don't want to share with your friends this thing, don't click this. So those below that, there is a protocol which takes care. It's taken care of. 5G is a two parts. One is that how quickly I will transport the information, which I presented to you today, the optimization of the protocols and all kind of things from top to bottom and all. But another part is that security, privacy, and all those are another complete independent particle in the 5G.
Okay, sir. Thank you so much. Thank you.
Thank you, Vaisali.
Hello, sir. Advi here. So thanks for the detailed session. I wanted to ask about the optimization part. So we are saying that according to the application that we are building, the need that the customer has, we will be providing a different service on the whole by slicing. But the IoT itself is evolving, and we are coming up with new applications and new devices and new kind of protocols. Today it might be Aadhaar and some other application that we are talking about. Tomorrow there might be something else. How adaptive is this slicing? As in,
very good practical question. Let me quickly go back to the previous picture and explain to you very practical question. See, when practically every applications will not have a set of protocols, difficult for practical deployment. What they will do in future, they will say 1 millisecond to 10 millisecond, whatever the application comes in. One application, say driverless car, say 1 millisecond, robotic operation, say 5 milliseconds. There may be a set of applications like 1 to 10 millisecond. They'll make a one category 1. So for that there will be this slice 2 kind of protocols will be there, and another one will be video conferencing, video call, say from 100 millisecond to 200 millisecond, another category. For them, another set of protocol will be there. For another is like that, a massive IoT, say from 200 millisecond to say 1000 millisecond for another slice. But if some IoT devices wants that delay should be between 1 to 10 milliseconds, then they will fall into slice 2. So they will make categories, category 1, category 2, category 3. According to your applications from the IoT, they will fall.
Can we switch between two slices? As in, let's say today I am making a voice call, and I am going to switch to a video call, or then I'm going to switch to a video conferencing. So in the same service, we are providing different kind of applications. So can we switch between the slices? Is it possible, sir?
Of course, yes. These are the research done in 2007 onwards. In IIT Bangalore, we did. There is something called, note it down if you have not done it, but IP Multimedia Subsystem, 2005, 6, to 2010. A lot of works happened across the globe. We used to work with NTT Japan, and there was another company in US and IIT Bangalore, and also HP Research Lab. So this is called IMS, IP Multimedia Subsystems Applications. Nowadays, I don't work. These are the works. Now people are using it too much. See, you very nicely said, I'm doing a voice call. I want to switch over to video. Same call. I don't want to disconnect that. That is called call orchestration. Okay, call orchestration. So the moment you switch over to video, I need more bandwidth for video. I need different kind of QoS, quality of experience for video. So the control signal will tell the backbone base stations, routers, till the destination, hey, allocate this session more bandwidth for this, and this is the QoS requirement for the video. Now he switched up. So you will not find any difference. You will smoothly transiting over to this. So this is called call orchestration.
But the slice will change as per the new architecture.
Slice will change. Everything will change behind. That is called.
And this will be seamless.
Seamless, absolutely. Not only that, you see, you are talking to say Professor Meenakshi, and suddenly you want to add me. You just touch on the add, and you just touch on my number. Automatically, I got added seamless. And you went on adding one after the other friend. And not only that, you drops also. Sir, your part is over. Now I am dropping you. You're dropping me. An interesting part, you are not you might not have seen. Your billing is happening behind. When you are talking to Professor Meenakshi, so you are paying 5 paisa per minute. Say when you add me 10 paisa. So that is also going in 1 millisecond level to the billing, charging, and millions of users. You are not alone using the network. Millions of users, and that speed. And there are 2 types of billing: prepaid, postpaid. Prepaid has to be very fast. Why? Because somebody's money is finishing, but he should not be enjoyed the network. So Reliance's and Vodafone will be very smart to see that your call get disconnected if money is not there in prepaid. Postpaid, no problem. So very, very interesting problems.
Sir, a related question.
Before you move ahead, I have to Professor Meenakshi's permission, because we have crossed time by 8 minutes. I have no problem. Professor Meenakshi, you may have
no problem for me, Professor Das. As long as you can take a couple of more questions, we'll be happy.
I have no problem. Please go ahead, because I don't know the other sessions.
No, next session is at 2 o'clock, so we have.
Okay. Good. Please go ahead. Who was asking? Please go ahead.
Yeah. So, just a related question, like when we are talking about network slices, it's not practically possible for everyone to move from 4G to 5G immediately. So the
Mm-hmm.
transition will be slow. So
Mm-hmm.
that means that at each slice for each application, we will be having heterogeneous devices which might be 5G compatible and which might also be on 4G or maybe 3G. If I talk about, like, there might be various kinds of devices. So
Mm-hmm.
how that sort of communication is seamlessly handled?
Yeah, that is another practical problem. I will add to your question, more question to that. You see, if you go to the many parts of this country, people are still using 2G network. Forget about 5G. And that number is not small, pretty big. And people still use that small black phone with their 2G voice and SMS. So they don't need videos and cost is cheaper and they're comfortable with that. So government has to slowly wipe out those 2G communications and say that from this and this date only 3G or 4G will be available. Like that, which will happen. Point number one. Point number two, again, if you remove that, the people who have bought the handsets, they have to buy again a new handsets, costly affair. So the future handsets, these handsets will be agnostic to all the Gs. I bought one, only I have same system will change in future. Only I have to download a software. That's all. One link will come, it flash on my screen, just touch it. Today's 4G phone will be 5G, which is not done yet. Future it will be. People are working on that.
Sure, sir. Thank you so much. Thank you.
Like
Sir,
your laptop. Your laptop, you don't change the new operating system comes, same hardware. Just you download.
Yes, sir. Yes, sir. Thank you.
sir,
Yes, sir.
Yeah, go ahead,
Sir,
Vaishali.
I wanted to know, is there any online framework or service available to directly push the SMSs based on the geographical location? Like, if somebody enters some area, then we can push some SMS through network.
You see, if you read SMS was very much centric to your local network.
Like,
Classical
yes.
SMS, 2G, 1990s, 1992 standard, if you read GSM, okay, and it is always local network center. If you are belong to Bangalore, even though you are in US, if you want to use the 115, it will be only for the Bangalore networks. Now, it will not show you the US local in the SMS. Okay, so
Yes.
people faced lot of problem due to that in SMS. Then it was solved in 2004 and 5 by a person who did PhD from IIT Bangalore. His work, if you look at, he solved those problems to make SMS localized. Okay, for many of these things. Okay, so coming to the point is that if you go to IEEE Explorer or some papers, if you look Ashok Talukdar, if you give search, you'll get those papers, how to make the SMS localized wherever I move in the world instead of
Okay.
local home network. Okay, this has been solved.
So that means it is possible that whenever some person enters in any geographical location, we can push some SMSs through
Yes.
local network.
Yes, it is a very interesting problem that got 2002 or 2003 Mobile Congress, one of the best project award also across the globe in Barcelona.
Okay.
If I do remember correctly, a long time gone.
Okay. Thank you so much, sir.
Welcome.
so now we are facing a problem that the existing 2G network signals affect our 4G communication, leading to some loss of information or data that is carried over the network.
Mm-hmm.
Can we expect that same problem to be faced in the 5G network too, sir? Such that 4G or 3G signals interrupt the 5G signals since they are very faster and these can't compatible with that speed. So, if there any problems arise with that interruption of signals?
No. Interference of signals will be taken care of very carefully by the service providers. Don't worry so much. There will be interference. I'm not denying that, but it will be taken care of because the bands will be allocated according to the available service providers. Point number one. Point number two, There will be beautiful filters are there in your systems here in mobile or in the base station to see that interference minimized. It is a big problem. It will be there always in our lifetime, but a lot of work has gone in. Don't worry.
Since recently BSNL 4G is facing the same problem, so that's why
I know. They're facing. I know, but it is a solvable problem. There are so many.
Thank you, sir.
Wireless communication, people are very smart. It's a very tough problem. Think nothing is visible in wireless, and signals coming from all sides. Base station is radiating. In my room here, I'm sitting. There are 4 walls and one roof and one floor, and signal is falling here, radiating and coming to my mobile from all directions. And I am able to hear you so clearly. I'm talking to you in video conference on this. So wireless is a very difficult beast to handle, but people are smart. Engineers, scientists are smart. They're solving this very nicely. And this is a well-known problem. Go ahead. Thank you then.